All right, welcome to our next video. This video is going to be on significant figures. And what significant figures do is it tells the reader of your data how accurate or how precise the instrumentation that you were using to get your measurements is. So sig figs are based on, like I said, the tools that we're using. So anything that's a constant that's already an accepted value, like the speed of light, for example, that would not factor into significant figures because we're not measuring that ourselves. It's something that's accepted by the scientific community. Sig figs, when we read our instrumentation, we always estimate the last digit. And so that tells the reader how precise we can get our information. So you can see here, we've got two different measurements, 3.53 meters or 3.534 meters. Well, the second one is going to be more precise because we know that they used a ruler that allowed them to get in and it had more divisions on it. So we're able to get the information, we're able to get the data to a much finer point than we would with the ruler that was used to gather this information. So let's take a look at a couple examples here. With this example, we see that we're dealing with a centimeter ruler here. This is going to be somewhere between 10 centimeters and 11 centimeters. And they've given us divisions here for actually millimeters. So if we were to read this for centimeters, we would see that it was 10.12345. We know that for sure because we can see the line here. And then our next digit, so 10.5, we can estimate where we fall in this section here. It's somewhere between 10.5 and 10.6. So we estimate that last digit. So our digit, our information that we would give for this would be 10.56, for example. If you wrote down 10.55, that would be fine too, because you're estimating that last digit. And as long as it's within reason, they'll give it to you. If you wrote down 10.51, that would be somewhere over here. You can see that that would not be an accurate answer. The point here is that we're able to get in that detailed because they have that many divisions here. And it tells the reader how many divisions there were on this particular ruler. So that's the purpose of significant figures. Here's another example. We have a graduated cylinder here, and we've got it marked off by milliliters. So here's 10, 11, 12, 13, 14, 15, 16. And remember, we read the bottom of the meniscus. So this is going to be somewhere between 16 and 17 milliliters. So I would estimate it around 17.8 milliliters. You could have written down 17.7, and that should be accepted as well because that last digit is estimated. Here's a thermometer. We have a Celsius scale here. We have 20. This would be 25. This would be 30. So we're estimating the temperatures here. So 20, 21, 22, 23. It's somewhere between 23 and 24 degrees. I would say 23.5. You could say 23.6. They would both be accepted because that last digit is estimated. So we have rules for determining how many significant figures we have based on a number that we're given. So all non-zero numbers are always significant. Anytime a number is between 1 and 9, always significant. Zeros between non-zero numbers are significant, and I'm going to show you examples of this on the next page. All final zeros to the right of a decimal place are significant. Zeros that count as placeholders are insignificant. And then either counting numbers, so if we're counting up how many people are in a classroom, or defined constants, we don't factor those in when we're figuring our sig figs. They're accepted values. So let's go back and let's look at some examples of these. First of all, non-zero numbers are always significant figures. So if we determine how many significant figures were in this answer, we would determine that there would be 3 significant figures here. By the way, we tend to refer to these as sig figs. It's just a shortened way of referring to it. So if you hear me say sig figs, that's what I'm talking about. Zeros that are between non-zero numbers are significant. So again, here we have 3 sig figs. This one's significant because it's a non-zero number, significant because it's a non-zero number, and this 0 is significant because it's between 2 significant numbers. Final zeros to the right of the decimal point. So here's our decimal. This is a final 0. It's to the right of that decimal point. This also has 3 sig figs in it. These are significant because they're non-zero numbers. This is significant because it's a final 0 to the right of the decimal point. Zeros that are just simply there as placeholders do not count as significant figures. So these 2 here are not significant. And another way to remember that is zeros at the front of a number are never significant. So this just has 3 sig figs. The next one here, 6 molecules, if we were counting how many molecules there were, 6 molecules would be a counting number. So that would be 1 sig fig. 60 seconds would also be because we were counting up the number of seconds. So that would have 2 sig figs in it. Here we're going to determine the number of sig figs in each measurement. So this has 4 significant figures because we end up having non-zero number, non-zero number. This 0 is between 2 significant numbers. And this guy here is a final 0 to the right of the decimal. Here we have, I'm going to pause for a second, let you think about it. Count how many you think we have. You should have said that we have 7 sig figs here, and I'll tell you why. Non-zero number, that's significant. Non-zero number, also significant. Non-zero, significant. This 0 is between 2 significant numbers, so therefore it's significant. This is a final 0 to the right of a decimal point, so it's significant. And if that's significant and this is significant, these are zeros between significant numbers. So every number in this is significant. Therefore, we have 7 sig figs. So take a second and see if you can figure out how many are in C. C has 5 sig figs. We have 1 here that's it's a non-zero number, a non-zero number. This is 0 is between 2 significant numbers, and these are final zeros to the right of the decimal point. This, our part of scientific notation, does not have anything to do with significant figures, so we completely ignore that when it comes to determining how many sig figs we have. So here's another one. See how many sig figs we have here. You should have said that we had 3 sig figs. This is a significant number, and this is a significant number because they're non-zeros. This 0 is in between them, so it's significant. These zeros, however, are just placeholders. There's no decimal here, so they're not significant because they're encased in a decimal. And they're not final zeros to the right of a decimal point. So therefore, they are not significant. That tells us that we only have 3 sig figs here. All right, figure out this one. For this one, you should have said that we had 5 sig figs. We have, remember, zeros at the front of a number are never significant, so these guys do not count. These 4 right here are non-zero numbers, and this is a 0 that's a final 0 to the right of the decimal point, so it would be significant. So 2, 4, 5. Take a second here, figure out B. For B, you should have said that we have 3 sig figs. These are the 3 sig figs. Remember, zeros at the front of a number are never significant. These 3 numbers are significant because they're non-zeros. For C, you should see for C that we have 5 sig figs. All of these are non-zero numbers, so they're all significant. And D, you should say that we have 2 sig figs here. Remember, zeros at the beginning of a number are never significant. And we have 2 sig figs here because they're non-zero numbers. So here again, answers, the same ones that I was doing as I was going through with you. Adding and subtracting them, when we're doing adding and subtracting, they have special rules. And when we're looking at sig figs, the final answer can only have as many significant figures as the least precise measurement. So the answer must have the same number of sig figs to the right of the decimal point. So you look to the right of the decimal point, and that's what you use to determine your significant figures. So if we were add up these, the answer should be to the 10th place. So whatever you have, whatever you end up with, you need to make sure that you have that answer, and the last digit is to the 10th place. Here, you're going to add these up, and whenever you calculate these, you need to come up with a value, and you can't have anything to the right of the decimal, because this doesn't have anything to the right of the decimal. This is to the hundredths place, this is to the tenths, but this is to that single unit. And then here, hopefully you were able to see that here, our answer would be to the 10th place. So I'll click on here and you can see the next slide and see what the answer should have been. So here you would see that we came up with something to the 10th place. So when you added all of these up, it was 142.9. Here, when we added these up, our calculator gave us a value that was had information off to the side there. So it came up to 768.41. But you're not going to write down the 0.41 because this guy doesn't have anything to the right of his decimal point. And here, this is to the 10th place. This is to the, this is to the hundredths place. This is to the thousandths place. So your answer comes out to the hundredths place. So when you type that into your calculator, you get 2.096. So 2.096, if we round that to the hundredths place, comes out to be 2.10. Multiplication and division then have special rules for it. For that, you count up the number of sig figs, and whatever whatever measurement that you had that had the fewest sig figs in it, that's how many has to be in your answer. So here we have a 2 sig fig number multiplied by a 3 sig fig number. So when we multiplied this out in our calculator, we came out with 78.24. But since our value here that was measured was only 2 sig figs, our answer can only be 2 significant figures, and that's why it's 78 meters squared. Here, if we take a 3 sig fig number and divide it by a 2 sig fig number, our answer can only be 2 significant figures. So when we calculated that out, it ended up being 2.016 repeating. When we write it out, though, we can only have 2 significant figures in our answer, so 2.0 would be the answer that we would write here. And it has to be 2.0. You can't just write down 2 and let it go, because that would only be 1 sig fig. So it has to be 2.0 meters per second. So for those of you who have asked me in the past week or two, how many numbers past the decimal do I round to? The answer from here on out for any of your chemistry classes is going to be significant figures. So that's what I'm going to tell you. Every time you ask me, how far should I round? I'll just say sig figs back to you. So if you're having trouble with these, you really need to come in and get some help, because these are not going away. We use them all year long. If you take AP Chem, we continue with them in there. So it's something that's just a continual thing for the rest of the year.